All right, we're going to work through a hypothetical secondary data analysis question using the UNO-STAR database. That's the database I've been referring to for this lecture so far. The UNO-STAR database is a national registry of transplant recipients. In particular, we're going to be focusing on people with thoracic diagnoses, aka lungs and or heart. In particular, we're going to be looking at people with different lung diagnoses. So this is our hypothetical secondary data analysis question. Does gender, age, oxygen requirements, BMI, or thoracic diagnoses, and we're only going to choose COPD or idiopathic pulmonary fibrosis, predict post-transplant transplant forced expiratory volume in 1 second. All right. So the documents for this are are on Canvas. Go take a minute, pause this, and go open those. At least open the data set, and then I'll refer you to specific documents as time goes on. All right. So first things first, we have to be familiar with our data and what we're going to do. So we know based on our research question, we're going to be predicting something, right? So FEV1. We need to know how this is categorized. So we should know by now through my examples that FEV1 is forced expiratory volume in 1 second. That is a continuous number. So we have a scale outcome. But if you remember, it's a percentage. So it could be 76% or 0.76. All right, so we need to know first how this is measured. Then we have to go through and find our individual predictors: gender, age, O2, BMI, and then thoracic. Whoops, that's wrong. Diagnoses. And it's going to be one or another, right? Since it's dichotomous. Do these things predict? So here, it's categorical. This is continuous for now. This, not sure. This, not sure, right? Because this could be in liters, or this could be do they require supplemental oxygen, or BMI. This could be continuous, or this could be category of BMI, and we know this is categorical. Okay, so we have to do some exploring first. All right, so let's first find gender. Let's look at that one first. I love this pen. So here, let's find it in our data set first. All right, this is the data set that you all should have open now. Here it is, gender, right there. So I gave you guys pretty much the full data set. Look at how many variables there are, 500 variables in this. So gender. So this is TCR. I'm going to save you some time. TCR means pre-transplant. If you see underscore DON, that means donor. So that's a donor variable. If it does not go underscore DON, it is the patient. So this is the patient of interest's gender. All right. So you can search this whole entire document if you want, the whole database, and look for gender. If you're not sure it's the only one, sometimes there are more than one. So if we do here, and then we do the search function, and we look at gender, there's only one. All right. Well, never mind, just kidding, there's two. Gender of the donor, see, underscore DO. See? And gender was the only two found. So we're concerned about patient's gender, not donor. So here we can easily see it's a string variable. Oh man. So it's not number based, unfortunately, and there's no values anywhere for this whole document. it will say none all the way down. That's one of the bummers, is that they don't code the values. We might have to find the values. Alright, so here we go all the way to the right, it's nominal, yada yada. So here, if you double click on gender, you can see it's M or F. We can't run statistics on letters. We have to recode this. So we know it's categorical. We know that we have to recode. So we have to recode gender. So we go to transform, recode into a different variable. We're going to find gender. There it is. Move it over. It's going to be gender new. Gender recoded to numbers. Alright. And so here we know our two values are M and F. So males, if it's an M, it is now going to be a 0. Females, or F, are going to be 1. Alright, continue. We've recoded our variable. We hit OK. It tells us what we did. And then it pops it up all the way at the bottom here. It should be all review, gender new. There we go. So here we always add our value. 0s are males, 1s are females. Okay, so great. So if we go back, we have checked off our gender variable. Age, we need to figure out if age is ready to go for us. So here we go to our data sets, highlight this, find, we'll search for age. Alright, okay. So there's a init age, which is waitlist age at listing in years. Okay, well, let's see. Age of the donor, okay. Age, recipient's age. Age group. Well, that's agent. That's not age. Okay. So we really found 3 ages. The age at the time they entered the wait list. So init age, age of the donor, recipient age. So that would mean how old they were at the time of receiving the organ. And then age group, and we don't know what that is. It's a string variable though. Let's explore this a little bit. It seems pretty much empty. If I'm just scrolling down, we're at our 65,000th patient, so this is a good review. There are almost 170,000 people in this data set. So the age group, they're either A's or P's. I'm going to go ahead and guess that's either adult or pediatric. But then what we can do is if you open your flat file or your Excel file that's uploaded in Canvas, we might be able to look it up. So we're going to go to, this is how it should open up for you. We're going to go to main documentation. We're going to go to our thoracic data. Age, recipient age in years. Here, right here, age group. This is what it means, recipient age group. A equals adult, P equals peds. Oh, right, we're fine with that. So we're going to ignore that. We're just going to go with age. Let's look at init age here just because we were considering it, and it's that. Age in years at the time of listing. So we're going to go with their age at the time of transplant, which is just age. Alright, so we're going to use just age. Now to simplify things, what I'm going to do is I'm going to move everything to the bottom of the data set. Or we'll move to the top. That's easier. So here. I'm going to highlight my new variable, and I'm just going to move it to the top, just so I know it's easier to keep things at the top here. I can't find age, so we're going to go age. Okay, we don't want init age. Age donor, we want age. Since we're okay with that one, we know that's the one that we want. Let's screen it. All right, so we already see there's missing variables. That's concerning. But here we go. So it's like they didn't collect age for a while, or they started collecting just asking people their age, or they had some sort of calculated way. So we can explore that if you want, but that would just take too long to figure out and go through all the documents to see when they switched over from just taking their birth date to just recorded age. So here we have about 100,000 people with age. I think that will do for our purposes. I hope you agree. So here, let's go. So age is continuous. We have figured that out. Now we have to explore O2. Does oxygen requirement pre-transplant affect post-transplant forced expiratory volume in 1 second? Well, let's see. We're going to go to labels here to search because there's more words. Let's go. Oxygen. All right, we're going to have a few here now. So here's exercise oxygen consumption. Sorry, I had to pause there for a second. So here, this is pre-transplant. Remember, TCR is pre-transplant or waiting list. Exercise oxygen consumption. That's not quite what we're interested in. All right, that was the only thing for oxygen. What if we do O2? Oh, okay, here we go. We have another option here. So this just goes to show you that there's not consistency here in the labels. It was oxygen spelled out here, and then it's also listed as O2. So you might have to search if there's many different ways to say a variable you're interested in. You might have to search a couple different ways. So here we have oxygen requirements at rest pre-transplant. Right below it, we have oxygen requirements at rest post-transplant, or at the time of removal. Look at this. So you can have post-transplant, at the time lungs were offered, at the time of removal, or current time. So it could be 1, 2, 3, 4 different oxygen readings. I personally like oxygen at rest prior to transplant at the time of listing. I think that's a little bit more clean. So let's see if there's others. Okay, so this is post-transplant. That's what TRR stands for. Transplant recipient. Post-transplant. Pressure of carbon dioxide. Nope. Post-transplant FiO2 at 72 hours, because most of them aren't going to be an event. Nope. Oxygen, pressure of arterial oxygen, post-transplant. Nope. O2 requirement at rest. Another same variable. Nope. 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 All right. So I like this one. Init O2. So we need to screen this. Init O2. All right. So this is full numbers. This is a scale. It's full numbers. There's some missing. So we have to figure out what that means. So it's init O2. We're here back in our Excel spreadsheet under our thoracic data file. Init O2. Oxygen requirements at rest, at listing. This is combined. You can see it's from the wait list data, which is a big part of this huge data set. Let's see. So it actually doesn't tell us how it's measured. So let's go to main documentation, back to contents. We're going to look up values here in our thoracic flap file. So we know it's oxygen, so this could get complicated. So we're going to search the document for O2. Couldn't find anything. Oxygen. Okay. Find all. Alright, next. Close. Okay. It doesn't tell us. It doesn't tell us anywhere. So we can do one last search. Nope. Find next. Nope. So it just tells us this is the only oxygen related thing that has coded values. So let's see, we might have to go into, sorry about that again for the random pause. Someone brought their dad in for a meeting with faculty. Don't do that. Just don't do that. Okay, but anyway. I have to think about where we were at. Oxygen. That's right. So we have to figure out how oxygen's coded. So I think we have to go in and try to find, let's see, code dictionary. I'm just going to, nope, it's not that. Important documents. I'm trying to find the ones that are on your guys' campus. Data collection tools. Nope, doesn't look like any of those. Let's see. A net oxygen is a TCR. It's a lung. Let's see if that's it. Just looking through here. Nope, wasn't that one. This one has 4. Let's see if it's any different. Nope. So this is becoming interesting because I found it once upon a time and I can't find it now. This is mildly embarrassing. Nope, not in there either. Where in the world? Where? Well, I can't find it, and I'm not going to take all your time. One last try here. Nope. Okay. Well, I found it, and I can't find it again, and I'm not going to pause and find it. You guys get it. You get the amount of work it takes to go back and look at it. So, this, a net O2, is actually liters of oxygen they're on at home, or rather post-transplant. So you can see some people are on high flow all the way up into the 20s. Some people are maxed out on 15. So there's plenty of data here. So we know a net O2 is in fact continuous in liters. That's good to know for our interpretation. So we're going to go to variable view. We're going to move it all the way up here because it's one of our variables. And so next is BMI. Alright, BMI is easy, it's right here. Let's do a search here, make sure that we're not missing it though. BMI. We're not interested in peds here. calculated BMI at listing. Okay, there's another BMI. BMI at removal. Donor BMI. Recipient BMI. Alright, so there's lots of BMIs. This, to figure out, because a couple of them were overlapping, what you would do here is you would have to go in to the file system, and you would have to figure out why TCR BMI, if it's different than calculated candidate BMI at listing, and calculated recipient BMI. Those are three variables, all saying the same thing. They're all the same. They're all pre-transplant BMIs. So, you would have to go through and read on every single one of these. So, here, I just happen to know that because this is, it's put here at the top when I was originally going through this data set, that BMI TCR is the most up-to-date BMI calculation for these people. The other two were old ways it was recorded that have changed over the year. So BMI TCR is what we're going to use. So here, check. It is continuous. It's not writing for me here, but it's continuous. And now thoracic diagnoses. It's categorical because we know we're looking for COPD and idiopathic pulmonary fibrosis. So what we're trying to do is find our diagnoses. So let's see, diagnose. All right, waitlist thoracic diagnosis. So LU or HL is heart or lung. Diagnosis grouping. Okay. Primary diagnosis at listing. Other text. Thoracic diagnoses from any form, TRR, TCR. Thoracic diagnosis text form, that's a string variable. Other. Okay. So waitlist thoracic diagnosis. So here, if we go on, so this is why they're on the waiting list. Waitlist, WL means why they're on the waiting list. So here, let's see if we can find diagnosis. Okay. So there's nothing in the document that says diagnoses. Okay, let's take a look-see here. Thoracic DGN. Okay, let's try DGN. Okay, there it is. Thoracic diagnosis. DGN. So here, there are a whole lot of thoracic diagnoses. Look at all these. Hundreds of them. Alright, so we're interested in COPD. So here it is. COPD. That are people coded 1607. And idiopathic pulmonary fibrosis. That's 1604. Now, this is why, if you did not screen your data, you'd be in a world of hurt. Because here, waitlist diagnosis, it's a numeric. It's on a scale. You right-click it, you're screening your data. Oh my god, you get a mean thoracic diagnosis. You have all of these different options. It makes sense that it's categorical, but here you could easily put it in as a scale variable if you weren't careful. So we know we need to recode our variable. So we're interested in people with COPD and idiopathic pulmonary fibrosis. So we said idiopathic pulmonary fibrosis, 1604. COPD was 1607. All right. Now there's a few different ways to do this. I'm going to tell you one and show you another. One way to do that would just be select cases of people with thoracic diagnoses equal to 1607 and 1604. That would filter out all people without those diagnoses. But then you wouldn't be able to put that into a statistical formula. So what I would do is I would transform. We're going to recode into a different variable. Get rid of this. We're going to go up here. Thoracic diagnoses. We're going to call it just diagnosis new. So it's going to be IPF or COPD. All right. So here, our value, we know that 1604, we're going to call it 0 for IPF. 1607 is 1 for COPD. All other values are missing. You could give it a different number if you wanted to, but we'll just, for the sake of this, all other values are now missing. Great. Okay. So now we have made it so that this is equal to 0, this is equal to 1. So now we know what gender is like, we know what age is like, we know what oxygen is like, we know what BMI is coded as, and we know what our now diagnoses are coded as. Now we have to figure out forced expiratory volume in 1 second. So we know it's going to be scale somehow, but we have to figure out how is it being coded. So we'll find FEV. Okay, here we are. This is exactly what we wanted. First try. TRR, which is post-transplant, forced expiratory volume in 1 second. Right here, it's a scale, it's a numeric, double click it, it's blank here, so there's missing values. Oh right, it's a whole number, it's a percentage and a whole number. So, that makes our life easy. You will call it this, and it is now. Thought I'd be able to cross it out. There we go. It is percentage there. There we go. So now, once we figured all that out, we're gonna go. We're gonna move it up here. We've made our new variable. Sorry, I skipped there. 0 is IPF. 1 is COPD. Okay. We're going to move it all the way to the top here. And so now we're going to do our, you can do your whole entire, all your bivariate tests, your correlations, your univariate descriptors, assessing for data normality, screening for missing data. So we'll just quickly just see what our sample size is going to be. So we'll just, these are all of our variables. Oh, we forgot to move BMI up, didn't we? BMI, TCR. Okay. Analyze, and then explore, if you guys forget. Explore will only include those people with complete data for all of these. Okay, statistics. We'll just run some descriptives on it, see what's going on. This is a big data set, so it's still running down here, as you can see. So this is very, very long to take some of these bigger analyses, especially Explore, because it's doing a whole lot, actually. So look at this. We have people with complete data for 17,386 people have complete data. So here are BMI. You can say our average BMI is about 26, just ever so slightly overweight. Mean on a categorical variable doesn't really matter, but just based off our mean, you can see, you can just postulate that a little bit more people have IPF than COPD, not by much. Forced expiratory volume in 1 second post-transplant, our dependent variable is about 38, which is not good. Oh, that's not good. So when you're interpreting this, we're not going to run the actual regression. I just wanted to show you the process that goes into it. It would be very important to know when this FEV1 is taken. If it's immediately post-surgery, of course it's going to be low. If it's a couple months after a lung transplant, well, maybe their outcomes aren't that great if their lung volume is only, 38% of what it could be, when normal is 80 or above. Oxygen requirements, so most people are hanging out at about 3.5 liters on the wait list. Average age is just about 60. And then here you can tell that more people are males than females, just based off this. So you can look at all of these if you want. BMI is pretty normally distributed. Ooh, we have some heavy skewness here. I wouldn't call it that heavy, actually. Stem leaf plots are kind of funky. But here's all these different outliers. Gonna ignore that. Looks good. So here you can just screen all the data. So once you're screening, you're doing all your descriptive statistics, your bivariates, your tests of difference if you want. Then you would go ahead and you'd run your regression and you would write it up. So this is secondary data analysis in a nutshell. This data set is huge. If this interests you, this is real data. This is 100%. I gave you guys real data. This is prime time secondary analysis territory for you all. If you're interested in any of the other different lung transplant organs that aren't heart and lung, let me know. I have that data. Then we can work together and write a paper if you want. This would be phenomenal for you guys as a student to have this big of a data set. I gave you guys all the basic tools to do it. Hopefully this made sense in terms of the logic of going through screening data, finding data, how complicated it can be, making sense of the data, just the principles of what we did. And I hope this was better than coming into class and learning about this on a Saturday. Let me know if you have any questions.